Okay, so we're going to talk about empirical and molecular formulas. So an empirical formula consists of the symbols for the elements combined in a compound with subscript showing the smallest whole number ratio of different atoms in the compound. So for an ionic compound, the formula unit is usually the compound's empirical formula. So, for example, say we had the ionic compound Mg2O2. Now, we want to reduce this into lowest terms, we would get MgO. So an ionic compound that is reduced into lowest terms is an empirical formula. And there's certain steps you need to take to get there. And they are, the first one, we're going to change the percent sign given in the problem to a gram symbol. Sometimes in the problem they will give it to you as a gram, but more times than not it'll be a percentage. So just change that percent sign to a gram. Then we're going to change the grams to moles. Then we're going to divide each number by the smallest number present. Number 4, the numbers you get after you divide each number by the smallest number are considered your subscripts. Number 5, place the symbol of each element next to the subscript that you found. And just a quick note, if you come up with a subscript of 0.5, multiply the whole compound by the smallest whole number to get rid of the decimal value. Now, example. So it says quantitative analysis that shows that a compound contains 32.38% sodium, so it'll be 32.38 grams of sodium, 22.65% or 22.65 grams of sulfur, and 44.99 grams of oxygen. So next, let's change these to moles. 1 mole of Na all over 22.99 grams of Na times 1 mole of sulfur all over 32.06 grams of sulfur. Now, times 1 mole of oxygen all over 16 grams of oxygen. So we calculate these. We have 32.38 divided by 22.99, and we get 1.408. I'm not going to round to 3 decimal points. I'll go. I'm not going to round to 2 decimal points. I'm going to leave it at 3 for right now. 22.65 divided by 32.06 gives us 0.7064. And then 44.99 divided by 16, and then we get 2.812. Now, what do we do next? We look at the 3 numbers we get, and we want to figure out which one is the smallest. And hopefully we all see that this 0.7064 is the smaller of the 3 numbers. So we're going to divide each of these 3 numbers by 0.7064. So 1.408 divided by 0.7064. I get 1.99, and that's very close to the number 2. 0.7064 divided by the same number is 1. 2.812 divided by 0.7064. 3.98, which is very close to the number 4. So now, our compound, we're going to write our element first, going left to right from the problem. So we have sodium, which is Na, and our subscript is 2. We have S, subscript is 1, and then O, subscript is 4. So our empirical formula here is Na2SO4. Now, that's how to do an empirical formula. Now, a molecular formula, so the empirical formula contains the smallest possible whole numbers that describe the atomic ratio. The molecular formula is as the actual formula of a molecular compound. So an empirical formula may or may not be a correct molecular formula. So the steps to solve a molecular formula. You might have to locate your empirical formula. You may have to solve for it. Might be given in the problem, you might have to solve for it. So number 2, you're going to divide the molar mass given in the problem by the molar mass of your empirical formula. And number 3, the number you found after you divided the above numbers needs to be distributed to each term in the empirical formula to come up with the molecular formula. So an example here. So in sample problem M, the empirical formula of a compound of phosphorus and oxygen was said to be P2O5. So that is our empirical formula. So experimentation shows that the molar mass of the compound is 283.89 grams per mole. What is the compound's molecular formula? So just like on the slide before, it said we're going to divide the molar mass given by the molar mass of our empirical formula. So let's do that. So we have 2 phosphorus at 30.97 apiece, and then 5 oxygens at 16. So we have 2 times 30.97, which is 61.94, and then 16 times 5 is 80. So if I add these up, we have 141.94 grams as our mass, molar mass, grams per mole, as our molar mass of our empirical formula. So we need to divide that with 283.89. So we have 283.89 divided by 141.94. And we get 2. So we have our formula, P2O5. And I like to write it as, and I'll come over here with this, P2XO5X. So wherever I see that X, I'm going to multiply it by the number 2. So my molecular formula would be P4O10. And that concludes our video on empirical and molecular formulas.